January 11th, 2026. The Philippine Institute of Volcanology recorded a number that broke every atmospheric monitoring protocol in their database. 777 metric tons of sulfur dioxide released from Mayon Volcano in 24 hours. To put that in context, it is enough poison gas to kill every living thing in a 200 square kilometre area. The readings were so extreme that scientists initially assumed equipment malfunction. No volcano at alert level 3 should be capable of this level of gas production. Satellite confirmation removed all doubt. Mayon had just achieved something unprecedented in recorded volcanic history. The discovery gets worse. Chemical analysis reveals this is not surface degassing from cooling lava. It is deep magma interacting violently with underground water systems, creating pressure conditions that only occur when volcanic systems approach complete structural failure. If Mayon can release nearly 800 tons of deadly gas while supposedly stable, what happens when the mountain actually decides to erupt? And why are evacuation models suddenly being recalculated for gas dispersal rather than just lava flows? Mayon Volcano, a towering stratovolcano in the Philippines' Bicol region, has a long and storied history of eruptions. Spanish colonial records dating back to 1616 document the mountain's consistent pattern of explosive activity, with an average of one major eruption every 8 to 10 years. Over the past 4 centuries, Mayon has experienced 49 significant eruptive episodes, each one partially destroying its perfect conical summit before rebuilding it anew. During quiet periods, Mayon typically emits between 10 and 50 metric tons of sulfur dioxide daily, a background level of degassing that poses little threat to surrounding communities. As magma begins rising beneath the summit in the weeks preceding an eruption, sulfur dioxide emissions gradually escalate, reaching 100 to 200 metric tons per day. At the peak of its explosive phases, Mayon has been known to release up to 500 metric tons of sulfur dioxide daily, coinciding with violent expulsions of ash and lava. However, the events of January 11th, 2026 shattered this predictable pattern. In a single 24-hour period, Mayon expelled a staggering 777 metric tons of sulfur dioxide, more than double its previous record for peak eruptive degassing. As Dr. Renato Soledam, director of the Philippine Institute of Volcanology and Seismology, emphasizes, in 40 years of monitoring, Mayon, we have never recorded single-day gas emissions exceeding 300 tons. 777 tons breaks every model we have. Historically, Mayon's eruption warning signs have followed a consistent sequence. First, a flurry of small earthquakes signals the ascent of fresh magma into the volcanic system. Next, the summit begins to swell and deform as the magma chamber fills. Gradually, over a period of weeks, sulfur dioxide emissions start to climb. Finally, the mounting pressure reaches a critical threshold, and the mountain explodes in a violent release of gas, ash, and lava. But the January 11th gas emission anomaly defies this established framework. The sheer volume of sulfur dioxide released in such a short time span, 15 times higher than normal pre-eruption levels, suggests a fundamentally different process at work. Chemical analysis of the gas plume reveals a composition consistent with deep magmatic sources, indicating that the sulfur dioxide is being generated by high temperature and high pressure interactions between molten rock and underground water systems. Despite the alarming readings, the Philippine Institute of Volcanology and Seismology has maintained Mayon's alert level at 3, stopping short of calling for a full-scale evacuation of surrounding communities. However, the sulfur dioxide cloud has already penetrated the stratosphere, posing risks to commercial aircraft and raising concerns about potential atmospheric impacts on a regional scale. As Dr. Maria Antonia Bornes, chief of the Volcano Monitoring and Eruption Prediction Division at the Philippine Institute of Volcanology and Seismology, cautions, "This gas release pattern does not match our eruption forecasting models. It suggests processes we do not fully understand are occurring beneath Mayon." While Mayon's emission of 777 tons of sulfur dioxide is unprecedented in the volcano's recorded history, other eruptions around the world have demonstrated the catastrophic potential of massive sulfur dioxide releases. The 1815 eruption of Mount Tambora in Indonesia injected so much sulfur dioxide into the stratosphere that it triggered the year without summer, causing widespread crop failures and famine across the northern hemisphere. In 1783, the Laki eruption in Iceland unleashed a continuous flow of sulfur dioxide that killed a quarter of the island's population and affected weather patterns as far away as Europe. More recently, the 1991 eruption of Mount Pinatubo in the Philippines released up to 500 tons of sulfur dioxide per day, resulting in a global cooling effect that persisted for 3 years. However, what sets Mayon's current activity apart is the absence of a full-scale eruption. The prevailing theory among volcanologists is that the sulfur dioxide is being generated by a process known as magma-water interaction. As rising magma penetrates the water table beneath the volcano, the intense heat causes the groundwater to flash into steam, creating a pressure cooker effect that rapidly expels massive volumes of gas. This interaction between magma and water not only amplifies the quantity of sulfur dioxide released, but also alters its chemical composition, producing a more corrosive and toxic mixture of gases. As Dr. Eric Clemetti, an expert on volcanic gas emissions, explains, when you see gas emissions jump from 50 to 777 tons overnight, you are looking at a fundamental change in the volcanic system. Something deep is happening. The implications of this magma-water interaction extend far beyond the immediate vicinity of Mayon. With the sulfur dioxide plume reaching the stratosphere, it has the potential to circulate for months, triggering acid rain across a wide swath of Southeast Asia. The resulting acidification of soils and water sources could devastate agricultural production in a region heavily dependent on farming and fishing. Moreover, the sheer volume of sulfur dioxide released raises concerns about potential impacts on regional weather patterns. Large-scale volcanic emissions have been shown to disrupt monsoon cycles and alter temperature and precipitation on a continental scale. With the Philippine monsoon season approaching, there is a risk that the toxic gases could be spread even further, affecting the health and livelihoods of tens of millions of people. Complicating matters further is the limited evacuation infrastructure in the rural regions surrounding Mayon. While the volcano's lava flows and ashfall hazards have been extensively studied and planned for, the threat of a massive atmospheric poisoning event presents a new and daunting challenge for local authorities. As Dr. Bornus notes, we are in uncharted territory. The immediate consequences of Mayon's record-breaking sulfur dioxide emission are already becoming apparent. With 777 tons of toxic gas released in a single day, a vast area extending more than 100 kilometers from the volcano has been designated as a respiratory emergency zone. Exposure to such high concentrations of sulfur dioxide can cause severe irritation of the eyes, nose and throat, as well as life-threatening respiratory distress. As the gas plume spreads, it mixes with atmospheric moisture to form acid rain, which has begun contaminating crops and water sources across the Bicol region, one of the Philippines' key agricultural areas. If the emissions continue unabated, they could potentially reach the densely populated metropolis of Manila, home to over 13 million people. In a worst-case scenario, the toxic cloud could blanket the entire Manila metropolitan area, overwhelming hospitals and emergency services. With the region's agricultural heartland compromised by acid rain, food security for millions of Filipinos would be jeopardized, leading to a cascading socio-economic crisis. The impacts, however, extend far beyond the Philippines' borders. As the sulfur dioxide plume drifts across the South China Sea, it threatens to disrupt international air travel, forcing the grounding of flights and the rerouting of shipping lanes. Neighbouring countries such as Malaysia, southern China and Taiwan could also find themselves grappling with cross-border atmospheric poisoning and agricultural damage. On a global scale, Mayon's gas emission event serves as a chilling reminder of the far-reaching consequences of volcanic activity in the age of social media and interconnected economies. With real-time documentation of the unfolding crisis spreading across digital platforms, the world is bearing witness to the first major volcanic atmospheric disaster of the 21st century. The event also underscores the complex interplay between volcanic emissions and Earth's climate system. If a single volcano can release enough sulfur dioxide to potentially alter weather patterns and disrupt agricultural production on a regional scale, it raises profound questions about the vulnerability of our global food supply chains and the resilience of our economies in the face of natural disasters. As Dr. Clive Oppenheimer, a volcanologist at the University of Cambridge, puts it, 777 tons of sulfur dioxide in one day puts Mayon in the same category as climate-affecting eruptions, except it has not even erupted yet. Despite the unprecedented nature of Mayon's ongoing gas emission event, 5OLCS, the Philippine Institute of Volcanology and Seismology, has thus far maintained the volcano's alert level at 3, indicating a high level of unrest, but stopping short of ordering a full-scale evacuation of surrounding communities. One of the key concerns among scientists is the possibility that Mayon's sulfur dioxide emissions could continue to escalate without the mountain showing signs of a traditional explosive eruption. In such a scenario, the silent release of toxic gases into the atmosphere could pose an even greater threat to public health and safety than the volcano's more familiar hazards of lava flows and ashfall. Complicating the situation further is the lack of a regional monitoring network capable of tracking the dispersal of volcanic gases on such a massive scale. While satellites and ground-based instruments can measure sulfur dioxide concentrations near the source, predicting the long-range transport and ultimate fate of the gas plume remains a daunting challenge. As Dr. Renato Solidum, Director of the Philippine Institute of Volcanology and Seismology, cautions, we are monitoring atmospheric emissions that exceed our crisis protocols, but the volcano has not technically erupted. We are in uncharted territory. Perhaps most alarming is the possibility that Mayon's behaviour could be part of a broader pattern of volcanic unrest in the Philippines. In recent weeks, other active volcanoes in the archipelago, such as Taal and Canlaon, have shown signs of increased seismic activity and gas emissions, raising concerns about a potential regional synchronization of volcanic systems. The implications of such a scenario are deeply unsettling. If multiple volcanoes were to begin releasing massive amounts of sulfur dioxide into the atmosphere simultaneously, the impacts on air quality, agricultural production and climate patterns could be catastrophic on a global scale. As the world watches the Mayon crisis unfold, a haunting question looms. If a single volcano can weaponize the atmosphere without erupting, how do you evacuate from poison gas that travels faster than people can flee? When volcanic disasters no longer require explosions, when the mountain quietly bleeds toxins into the air we breathe, where exactly is the safe zone? And perhaps most terrifying of all, if this is what Mayon releases during stable activity, what atmospheric apocalypse awaits when the perfect cone finally decides to erupt? The 777-ton gas cloud continues drifting across Southeast Asia tonight. Satellites track its movement, models calculate its dispersal, but somewhere beneath the perfect symmetry of Mayon's cone, forces beyond human control are turning the sky itself into a weapon. The mountain may not have erupted, but it has already begun killing from a distance. Stay ahead of the unfolding volcanic gas crisis and other earth-shattering events with Earth attacks. Subscribe now for exclusive updates and analysis from the world's leading experts, and join a community committed to understanding and preparing for the next chapter of our planet's tumultuous history. With your support, we can continue to shed light on the hidden forces that shape our world and work together to build a safer, more resilient future for all.